Okay, let's take a quiz over what we've learned today. So, question number one. The theory which states that the Earth is the center of the universe is called the geocentric universe. Question number two. A watt is the smallest unit of an element that still has all the properties of that element. That's an atom. Okay, question number three. What is a terrestrial planet, or how is a terrestrial planet different from a Jovian planet? Okay, so what is a terrestrial planet composed of? Rocks. Okay, so what is a Jovian planet composed of? Gases. Okay, where do you find a terrestrial planet? In the inner part of the solar system? Where do you find a Jovian planet? In the middle part of the solar system? Okay, so there were some various ways of telling the difference between a terrestrial and a Jovian planet. Question number four. What can forces do? So they can do three things. So they can change the speed of an object, they can change the direction that an object is moving in, and they can change the shape of an object. Number five, the faster something is moving, the more what kind of energy does it have? That would be kinetic. Okay, question number six. What were the conditions like right after the Big Bang? So the universe was very small. Okay, the universe was very hot. The universe was very dense. The universe was composed of very simple particles, like quarks. Question number seven. How do stars make elements heavier than helium? Okay, this is, so stars, when they're living, take hydrogen and turn it into helium. But then, when the star begins to die, it starts to run out of hydrogen, usable hydrogen, and then as the core contracts, it heats up, and it's possible to make heavier elements than helium. So this is when the star is dying. Then when it gets to, if it's a very, very big star, it can manufacture iron. And when it does that, then it's going to go supernova and explode. And then when it explodes, it can forge all of those other elements that are heavier than iron. So that's basically where all of the elements in the periodic table came from. Question number 8. Earth is approximately how many years old? So from a scientific standpoint, it's about 4.6 billion years old. Number 9, put the following steps which describe the formation of the solar system in the correct order. So what would have been the first thing that would have happened? The gas cloud would have collapsed into a disk. Okay, then the second thing that would have happened would have been rock and ice and gas separate because of temperature differences. Okay, then the next thing that's going to happen is that the solar wind is going to blow any remaining gas out of the solar system. And then finally, the planets are going to differentiate. So that means that the heavier elements inside the planets are going to fall down towards the core. Okay, number 10. Why did most of Earth's iron end up in the core? Because it's more dense. And so less dense things float on top of more dense things. So the densest stuff inside the Earth is the iron and nickel, and so it went down to the core of the Earth. Question number 11. Earth's magnetism is due to, it's due to electrical currents in the core. So in the outer core, as iron and nickel are circulating, because of the spin of the Earth that causes electricity to be generated, which causes magnetism, and then the magnetism in turn causes the electricity to form. Number 12. The components of the Earth system are the geosphere, the atmosphere, the cryosphere, the hydrosphere, and the biosphere. Number 13. The Earth is hot on the inside for all of the following reasons except magnetism. Question number 14. What is the name of the part of the Earth which is sliding on the asthenosphere? That would be the lithosphere. All right, and so there you go. So that's the end of this lesson, and I hope that you'll come back for our next lesson in which we're going to start talking about plate tectonics.